Okay, well, let's review Chapter 5 on probability reviews for the exam. You'll notice that there have been some multiple choice questions and a couple of free response questions that have to do with probability. Probability from Chapter 5 is mostly multiple choice and every now and then free response. Excuse me. So in Chapter 5, we learned some basic probability rules. The complement rule, the probability that something does not occur is equal to 1 minus the probability that it does occur. The addition rule, there are basically two addition rules, but you can really think of just the one, this one right here. The probability rule says that the probability of A or B is equal to the probability of A plus the probability of B if A and B are mutually exclusive. Mutually exclusive means they can occur at the same time. Cannot occur at the same time. The addition rule can also be the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B if they're not mutually exclusive. The multiplication rules, there are two of them. The probability of A and B occurring is equal to the probability of A multiplied by the probability of B if A and B are independent. The outcome of one does not affect the outcome of the other. The multiplication rule can also be the probability of A and B equals the probability of A multiplied by the probability of B given A if they are not independent. So let's point out an example of each of these. Draw a card from a deck of 52 cards. What is the probability that it is not a 5? Well, that's equal to 1 minus the probability that it is a 5, which would be 1 minus 4 out of 52, because there are 4 5s in the deck. So that would be 48 over 52, and of course grab your calculator and get a percent. Draw a card from a deck of 52. What is the probability that it is an ace or a king? Well, ace and king are mutually exclusive. So then that means this rule applies, and this is just equal to the probability of ace plus the probability of king. So that would be 4 over 52 plus 4 over 52 equals 8 over 52. Grab your calculator. What is the probability that the card is an ace or is red? Those two things are not mutually exclusive because there are red aces. So if we use this formula, that would be equal to the probability of ace plus the probability of red minus the probability of red ace. So then that would be 4 over 52 plus 26 reds out of 52 minus 2 out of 52 because there are 2 red aces, the ace of hearts and the ace of diamonds. So that would be 28 out of 52, and you grab your calculator. Now, suppose that we draw 2 cards. What is the probability that the first card is an ace and the second card is a jack? Well, ace and jack, those are independent things. So that's equal to the probability of ace multiplied by the probability of jack. So that would be 4 over 52 times, did we replace the first card before drawing the second? Or did we not replace? Well, if we did not replace, then there's a 4 out of 51 chance that the second card is a jack. What is the probability that both are aces? Well, those two things are not independent because the outcome of the first draw being an ace has an effect on the second draw. So that would be equal to the probability of ace multiplied by the probability of ace given ace. And basically what this means is, given that the first was an ace, what's the probability that the second was an ace? That would be 4 over 52 times 3 over 51. Okay. All right. Conditional probability. The conditional probability formula, the probability of B given that A occurred is equal to the probability of B and A divided by the probability of A. This is your conditional probability formula. It helps you with some problems, but other problems, conditional probabilities are simple and you may not need this formula. We'll show you that in just a minute. It was reported that 79% of teenagers use social media. P social equals 0.79. 31% of teenagers who use social media feel pressure to post. The probability of pressure given that they use social media is 0.31. See, that's the conditional statement right there. 31% of teenagers who do use social media, in other words, given they use social media, they feel pressure. What is the probability that a randomly person uses social and feels pressure? Well, the probability of social and pressure is equal to what? So then, let's see, using my conditional formula, the probability of pressure given social is equal to the probability of pressure and social divided by the probability of social. So then substitute 0.79 for social, and pressure given social 0.31 goes here, and social and pressure is our unknown. So then doesn't that say that x equals 0.31 times 0.79, and multiply and get your answer? So it usually helps to write down what you're given symbolically, and it helps you know where to substitute. Now, two-way tables and probability. Usually, if you're given a two-way table with probability questions, they're very simple. Even these two conditional problems, you don't have to use the formula. I'm going to try and remind you of that. So here's a two-way table. Apparently 625 people were surveyed. They identified which political party they're a part of, and they identified their gender. Okay, so choose one of these people randomly. What is the probability, that the person is either a Republican or an independent? Well, there's 220 Republicans and 120 independents. So can I say that this is equal to the probability of Republican plus the probability of independent, and being that they're mutually exclusive, 220 out of 625 plus 120 out of 625 equals 340 out of 625. Grab your calculator and convert that to a percentage. What is the probability that a person is a Democrat or a female? Well, you'll notice that these things are not mutually exclusive. So this time we have to say this is equal to P of Democrat plus P of female minus the probability of Democrat and female. So that's going to be 275 out of 625 plus 340 out of 625 minus Democrat and female, 150 over 625. So you just grab your calculator and get that numerator out of 625 and you're done. Okay, now what is the probability that the person is a Republican given that the person is a male? So given that the person is a male means, hey, given that it's one of these people, what is the probability that it's a Republican? Well, of those people, 100 of them are Republicans, so this is 100 out of 285. But then if you switch it around, what is the probability that is a male given that the person is a Republican? Well, that means this time if we're given that the person is a Republican, we're talking about just the Republicans. And of them, 100 are male, so this is 100 over 220. So hopefully you can look back and remember that probability from two-way tables. Notice on these two problems, I did not use the conditional formula, but that it would work. Venn diagrams. Using Venn diagrams and how to know when to use it. When you read a word problem like this one, where it says, and a certain percentage do both things, that's usually your hint when you should use a Venn diagram. So let's try this out. Suppose that 54% of seniors take AP Statistics, 32% take AP Calculus, and 20% take both. I would immediately draw a rectangle, and I would draw two circles overlapping, and let one be stat and the other be calculus. And the minute I read that 20% take both, I put a 0.20 in here. Now, if 54% take AP Statistics, then I need a 0.34 in the rest of the statistics circle because I want the sum of those two numbers to be 54%. 32% take AP Calculus, so if I put a 0.12 here, that's 32% taking calculus. Now, if I add 0.34, 0.20, and 0.12, it looks like I get 0.66. So then 1 minus 0.66 is 0.34. I put a 0.34 out here, meaning that 34% of seniors take neither. Okay, remember that the sum of all of the numbers in a Venn diagram must be 1 or 100%. Okay, now before we start answering questions, let's talk about this. The 0.34 is the students who take statistics but not calculus. These are the people that take calculus but not statistics. These are the students that take both, that was given. And these are the students that take neither. Okay. Pick a senior randomly. What is the probability that the person takes just statistics? Oh, that's the 0.34 over there. What is the probability of taking neither? Well, that's the other 0.34. What is the probability that the student takes statistics given that the student takes calculus? Well, you better use the conditional formula when you encounter a problem like this. So let me show you. The probability of stats given calculus is equal to the probability of stats and calculus over the probability of calculus. So that would be 0.2 over 0.32, 0.2 over 0.32. So the 0.2 is taking stat and calculus, and the 0.32 is the calculus that was given. What is the probability of calc and stat? Well, that would be equal to the probability of calculus given statistics would be equal to the probability of calc and stat divided by stat. Well, that's 0.2 over 0.54. Okay, stat or calc. Well, that would be equal to the probability of stat plus the probability of calc minus the probability of stat and calc, the addition rule. So that would be 0.54 plus 0.32 minus 0.20. Get your answer. What is the probability of stat given, not calculus? Well, that would be equal to the probability of stat and not calculus divided by the probability of not calculus. Well, let's see. The denominator, not calculus, that's these people and these people. So the not calculus people is 0.34 plus 0.34. Okay, now, whoa, sorry, I actually messed up. Stat takes stat and does not take calculus is these people. So the numerator is 0.34. Now, not calculus is these people. Boy, did I almost screw up. Not calculus. Nope, that's not right either. Not calculus is these people and these people, so that would be 0.68. Sorry about that. On the upcoming video, I'll work through some more examples. If you feel comfortable after just these review problems, don't feel compelled to watch the next video, but there are more worked out examples.